looking at 4A2. I do not know what happened to the top of this page, but it did get cut off. So I'm going to write in here that this is graph shows the height of a ball being hit. Alright, so now we're putting these things into real world context. I know what this is about. This is about a ball being hit. So, what is the maximum height? Oh, there's another question missing. Sorry, it all got something got off. The first thing we want to find is the vertex. So, our vertex is our highest point or lowest point. Right, my vertex here is 1, 4. So the first thing it's asking us then is what is the maximum height of the ball? Okay. Well, remember, height is going to be your y value. This axis represents height. Okay. So height is going to be your y value. Well, the highest, right, the next tallest my ball ever is 4, I'm just going to make up that the unit is feet. That ball is 4 feet in the air. Okay. Then, our x-axis, right, this one is time. Right, so we have time versus height. So the next question one is asking, when did the ball reach its maximum height? This is asking about the x value. Okay, so it's a when question, it's time, x. So what was my x value? Well, it reached its maximum height after 1 second. Explain the x-intercept. Again, x-intercept, all x values have to do with time. My x-intercept, remember we talked about the beginning of the last video? It's the time when the ball hits the ground or lands on the ground. So our x-intercept is the time when the ball hits the ground. So when did the ball hit the ground? Well, my x-intercept here is at 3. So the ball hits the ground after 3 seconds. Up in that air for 3 seconds. Explain the y-intercept. Well, again, y always has to do with height. So just like x-intercept is the time when the height is 0, the y-intercept is the height when time is 0. We're going to say the initial. Remember, initial just means at the beginning. Height of the ball. Okay. So again, the initial, or the height at the beginning, height of the ball. So what was the initial height of the ball? Well, looking here, right, my initial height was 3 feet. Okay. All right, let's look at another example. Okay, so the following graph shows the height of a dolphin jumping out of the water. So again, let's start with what is my vertex. All right, well, my highest point, it looks to be about 4. It's a little above 15. It's 16, I think. So 4, 16. Again, this axis is height. This axis is representing time. So what is the maximum height? Well, again, height is y value. So my maximum height was 16 feet. All right, and so then when does the dolphin reach its maximum height? Remember, the question when has to do with time. So it's which is an x value. Okay, we'll go with that time, so an x value. And the x value of that maximum was 4 seconds. So again, explain the x-intercept. The x-intercept is when height equals 0, right? So it's here, right? That's when my height equals 0. So the x-intercept is the time when, well, if the height equals 0, then the dolphin is landing in the water. So the time when the dolphin lands in the water. So how long was the dolphin above the water? Well, he started here at 0 seconds and he ended here at 8 seconds. The dolphin was in the water from 0 to 8, or really 8 minus 0, which equals 8 seconds. The dolphin was above the water for 8 seconds. Explain the y-intercept. Well, run. Y-intercept is when time equals 0. So it's the initial height remember again, initial just means at the beginning. So the initial height the dolphin started from. So here, right, where it crosses this axis, my initial height is 0. So 0 feet above the water. All right, let's go ahead and turn to the next page. The next thing we're going to look at was deciding what is, right, finding the maximum height, all those things is when we have a table instead of a graph. Okay? So the first thing we want to find is our vertex. And to find the vertex, we're looking for the highest or lowest number, but it can't be the first or last thing in your table. Okay? The highest slash lowest number. So my lowest numbers are 0. Sorry, my highest numbers are 0, and my lowest number is -4. Okay? Well, I can't have it be first or last, so it has to be that -4. Okay? Because this graph can continue on, it's just stopped here. Okay, so it just can't be that first and last. We don't know what continues to happen. So my vertex is 2, -4. Does this function have a maximum or a minimum? It has a minimum. Because it's the lowest number. All right, interpret the meaning of that maximum minimum. Well, we're talking about a submarine. So the submarine was at its lowest, we could say height, but with a submarine, we're going to talk about depth. If you say height, though, it's not wrong. So lowest height / depth. Okay. Of, well, what was its lowest? Well, of 4 feet, or 4 submarines, we'll go with miles. 4 miles below, that's what the negative means. You wouldn't say it's negative 4 feet. We would say it's like 4 feet under the ground or 4 feet under the water, so 4 miles below. After 2 hours. Okay, we have to have both the time and the height in there. Okay, so this doesn't have to be written exactly. You can say after 2 hours, it was at a low depth of 4 miles, lowest depth of 4 miles. To kind of rearrange it, but you have to have both these numbers in that explanation. Okay, identify the t-intercept. Remember, your t-intercept is where height equals 0. Okay. Well, we have height equals 0 here and here. So my t-intercept is 0, 0, and 4, 0. Okay. So remember, identify the meaning. We're talking about height being 0. Okay, so it's at sea level or level with the ground. So the submarine is at sea level. Again, that's like the ground in our other problems. At 0 hours and 4 hours. Okay. Once again, when your height equals 0. Identify the h-intercept. Remember, your h-intercept is where time equals 0. Check, I'm going to look under time. 0 here. 0, 0. Interpret the meaning. Again, where time equals 0 is our initial. So the initial, again, remember to use depth, be fancy. Depth of the submarine was 0 miles, also known as sea level. Okay. Alright, so that's it from a table. Alright, let's look at our second example like this one. Again, our vertex, lowest or highest. So our lowest, and 14 is our highest. Again, we can't use our lowest because it's at the edge of the table. So this one has a vertex of 2, 14. Does the function have a maximum or a minimum? It has a maximum because it's the highest number. Interpret the meaning. Okay. So at 2 seconds, remember for the meaning we have to represent both these numbers. X is time, Y is height. So at 2 seconds, we're talking about a baseball here. I don't know what, I just wrote possible and it was supposed to be baseball. Sorry about that. I don't know what was in my mind. The baseball had max height. That's the other thing that needs to be in it. Right? Is it max or min? Highest or lowest is fine too. A max height of 14 feet. 14 feet. All right, looking at the next one, identify the t-intercept. Again, the t-intercept is where height equals 0. So looking under height is 0 here, so my t-intercept is 5, 0. Interpret the meaning. Well, it's the time when my height is 0. So after 5 seconds or at 5 seconds, what does it mean in the real world when the height is 0? Well, the ball lands on the ground or hits the ground. Alright, so again, kind of bringing it back to what's actually happening in the real life situation. Alright, identify the h-intercept. Again, h-intercept is when time equals 0. So looking at our time, 0 there, 0, 6. Okay, remember, if time is 0, that's the beginning. So the, say, initial height of the baseball was 6 feet. Okay, so we kind of think, what does that actually mean? The person who was hitting the baseball was probably around 6 feet. All right, so that's where it was hit from. All right. I'm throwing guns probably. All right, that is it for target A. Go ahead and work on the activities.